All right, welcome to the second part of chat section 10-4. And now we're going to be looking at dividing rational expressions. And to divide rational expressions is just a little bit different than multiplying, because we know when we are multiplying fractions, you do the good old keep, change, flip. So that's what our first step is. You're going to change the division. You're going to change the division to multiplication. And then you're going to take the reciprocal. Again, reciprocal means you flip the fraction of the fraction you're dividing by. This changes the problem into multiplication. So if you want to make a note, this first step is really the keep, change, flip. After that, now you're going to follow the multiplication rules or steps from the previous page. All right, so if we look at our examples here, again, I see division first. So the first thing I'm doing is keep, change, flip. I'm keeping that first fraction the same. Changing our division to multiplication, and then I have to flip my second fraction. All right, so now it's a multiplication problem. So if you go back to your steps for multiplication, the first thing you're going to do is look to factor. So I'm going to factor everything I can. So x squared minus 1, there's no GCF, but they are both perfect squares, and they're both being subtracted here. So I take the square root of x squared, which is x, square root of 1, which happens to be 1 as well. And remember, we always have opposite signs for difference of squares. For the bottom, there's no GCF. There's 3 terms with the 1 in front of my x squared, so I am salmon factoring that. So again, as you can see, factoring is so important. All right, so what multiplies to x squared would be x times x. What multiplies to negative 7 adds to negative 6. The only thing that multiplies to 7 is 7 and 1. It's multiplying to be negative, meaning I need opposite signs. And since it adds to be negative, my bigger number needs to be negative, so my smaller one is positive in this case. So x minus 7 and x plus 1. So I go to my second fraction, x minus 7, there's no GCF, and it can't be factored any further because they're not perfect squares. So I'm just going to put that in parentheses to note that it is factored as best can be. And then for the bottom of the second fraction, I am going to have to salmon factor that. So I get x times x gives me x squared, what multiplies to negative 2 and adds to 1. So that'd be 2 and 1. They're going to have to be opposite signs and add to be positive, so my larger one is positive. So plus 2 minus 1. All right, now that we're factored, we can look to cancel out any like factors on the top with any like factors on the bottom. So I have x plus 1 on the top with an x plus 1 on the bottom, an x minus 7 on top, x minus 7 on the bottom, and an x minus 1 on top, x minus 1 on top. So I'm left with nothing on the top, which means when things cancel, they cancel to 1, so I'm left with a 1 on top. And the only factor I have left on the bottom is x plus 2. Don't forget your restrictions. Again, you're setting each denominator factor equal to 0, and also division is going to be a little different. We'll talk about that in a second. So this first denominator factor is x minus 7. If I set that equal to 0, I get 7. 7 minus 7, 0. X plus 1 equal to 0, I get negative 1. Negative 1 plus 1 is 0. Here I have x plus 2, so that would be minus 2. Negative 2 plus 2 is 0. Positive 1. And for division, it's a little different. You also have to do the numerator and denominator of the second fraction because remember, this x minus 7, although it was in the top at the end, it was originally on the bottom. So you got to restrict all factors of the numerator and denominator of the second fraction for division. In this case, we already have that restriction because 7 minus 7, 0. So we are finished. All right, if we look at example 2, remember, although this looks different, it looks like two big fractions in one. This division bar here means, this fraction bar really means division. So the first thing I'm going to do is I'm going to keep this the same. I'm going to change that division bar, this one right here, to multiplication, and then I can flip this second fraction. So I have x minus 5 on top and 4x squared minus 1 on the bottom. All right, so now it's a multiplication problem, so I'm going to factor. For 2x plus 1, I'm going to look to pull out a GCF first, which I don't have one. And there's two terms and neither are perfect squares. Well, one's a perfect square, but 2x is not, and they're being added, so I can't factor that, so I just put it in parentheses. I go to my second one, there's no GCF, but x squared is a perfect square, so is 25, and they are being subtracted, so this one would be difference of squares. So x times x gives me x squared. The square root of 25 is 5. And then we have 1 plus and 1 minus. All right, as I go to the top here, I have x minus 5. There's no GCF, and x and 5 are not perfect squares, so I'm leaving it as is, just putting it in parentheses to note that it is factored. And then on the bottom, 4x squared minus 1, there's no GCF, but 4x squared, those are both perfect squares. One's a perfect square, and they are being subtracted. So again, I have another difference of squares. So the square root of 4x squared is 2x, and the square root of 1 is 1. We have 1 plus, 1 minus. Now that we're factored, I can look to cancel. So a 2x plus 1 cancels with a 2x plus 1, x minus 5 with an x minus 5. So again, we are left with a 1 on top and an x plus 5 on the bottom. We also have a 2x minus 1 on bottom. All right, we still need our restrictions. So x cannot equal. If I set x plus 5 equal to 0, I'd get negative 5. Negative 5 plus 5, 0. X minus 5 equal to 0, I get positive 5. 5 minus 5 is 0. And then again, it's always a little trickier when you have a number in front, like coefficient. So if I just do this for the first one, 2x plus 1 equal to 0, I'd have to subtract 1 and then divide by 2. So negative 1/2 would be 1. And if I set 2x minus 1 equal to 0, I'd have to add 1 to the side and then divide by 2, so I get positive 1/2. Remember, with division, you also have to do the top and bottom of the second fraction, but the top of this one, x minus 5, is 5. I already have that. And then for example 3, again, first thing I'm doing is keep, change, flip. So my first fraction is going to stay as x plus 3 over x minus 3, changing the division to multiplication, and then I have to flip this second fraction. 3x minus 9 over x squared minus 9. Again, I can't cancel anything right now. What I do have to do is try to factor. So x plus 3 can't factor. I'm just going to put that in parentheses. X minus 3 can't factor. I'm just putting it in parentheses. 3x minus 9, that can factor because there's a GCF. So I'm going to put 3 is the GCF. I can divide each of the terms by 3. And when I divide each by 3, 3x divided by 3 is x, and negative 9 divided by 3 is minus 3. So again, all I did was put my 3 in front, divide each of my numbers by 3. And then I have no GCF for the bottom, but it is difference of squares. So the square root of x squared is x, square root of 9 is 3, and 1 plus, 1 minus. Now I can look to cancel. So an x plus 3 with an x plus 3, and x minus 3. Now on the bottom I have two x minus 3's. It's only going to cancel with one of them, so I'm just going to do it with this one. So I am left with, on top, a 3, because there's nothing else left besides that factor of 3, and then x minus 3 on the bottom. All right, and then I'd say x cannot equal 3, because 3 minus 3 is 0. Negative 3, because negative 3 plus 3 is 0. And then I also have these other ones already, so that's all I got. All right, I want you to try doing number 1 right now. For number 1, again, you do keep, change, flip. At the same time, we're also going to have to factor. So I'm going to flip this and change it to multiplication kind of at the same time. Well, we'll do it once. All right, so x squared plus 12x plus 36 over x squared plus 3x minus 18. Changing the division to multiplication, flipping the fraction. So x squared plus 4x minus 21 is on the top. And then x squared plus 11x plus 30 is on the bottom. All right, so now I got a lot of factoring. And this is all going to be SAM factoring. I know it's all SAM factoring because there's no GCFs in here. There's 3 terms for all of them, and there's a 1 in front of all my x squareds. So it's a lot of SAM factoring. All right, so I have multiplies to x squared is x and x. And then I'm saying what multiplies to 36 and adds to 12. So that would be positive 6 and positive 6, because 6 times 6 is 36, 6 plus 6 is 12. On the bottom, multiplies to negative 18 and adds to 3. So my factors of 18 are 1 and 18, which isn't going to work. 2 and 9 does not add to 3. 3 and 6 can add to 3. So I'm going to do 3 and 6. They have to be opposite signs because they're multiplying, and add to be positive. So my larger number, which is the 6, has to be positive. Smaller one is negative. All right, some more SAM factoring. Everyone's favorite. Actually, I really do like SAM. SAM I am. All right, x squared plus 4x minus 21. Multiplies to negative 21, adds to 4x. So that'd be 7 and 3. Again, it's adding to be positive, so my larger one has to be positive, and they're opposite signs. So 3 is negative. They have to be opposite signs. And my last one multiplies to 30 and adds to 11. It will be 5 and 6. They are both the same sign because they're adding to positive, and the larger one has to be positive because it's adding, so they're both positive. All right, we're factored, so now we can finally cancel. So I have x plus 6 with an x plus 6. There's another x plus 6 and an x plus 6 down there. And x minus 3 with an x minus 3. And this is one good one. Lots canceling out. Feels like you're checking things off your to-do list. So, all right, so we would be left with x plus 7 on the top, x plus 5 on the bottom, and then we do our restrictions. So 3 minus 3 is 0, so x cannot be 3. Negative 6 because negative 6 plus 6 is 0. All right, negative 5. Negative 5 plus 5, 0. We already have the negative 6. Remember, for division, we have to do top and bottom of just a second. So I'd also have negative 7 up there. Negative 7 plus 7, 0. And then we already have the 3. All right, try the other 3 on your own. And then you'll need to check the answer key in our Google Classroom for the double check to make sure your answers work.